Hey everyone, in this video I wanted to talk about COVID clots. So one of the scary manifestations of COVID and the SARS-CoV-2 virus is the formation of clots, which then can lead to heart attacks, strokes, and pulmonary embolisms. So in this video I wanted to talk about the mechanism of how those clots are being formed and some things we could potentially do or take to help mitigate the effects of the clots in this virus. Different RNA viruses can form these clots, but it's particularly happening with the SARS-CoV-2 virus in a greater degree. So here we have a cross-section of a blood vessel, and the blood vessel is lined with these cells called endothelial cells. The endothelial cells line and create the lining of the blood vessel. So inside the blood vessel we have the SARS-CoV-2 virus floating around with this little corona spikes. And the virus attaches to something called ACE2 receptors that line endothelial cells, and they're actually expressed more highly in endothelial cells, blood vessels, than other cells of the body. So the virus attaches to the ACE2 and then gets enveloped and enters the cell. Something that also happens with the virus is we're noticing an increased number of circulating antibodies called anti-phospholipid antibodies. These antibodies have the same effect on the endothelial cells, but there's just more of these, so there's a greater effect happening with the SARS-CoV-2 virus. So here we're going to see a blown up version of what happens. The virus with its spikes attaches to the ACE2 receptor and then gets enveloped in these endosomes that get taken up into the cell. So the endosome looks like a circle with now the virus and the ACE2 receptor inside here. Inside the endosome is something called toll-like receptor 7. This is a specific receptor that reacts to the presence of RNA. The toll-like receptor 7 triggers something called NADPH, which then triggers something called tissue factor. Now, tissue factor is the main danger signal of the body to start forming clots. So anytime you hit yourself or you break a blood vessel, tissue factor is released from endothelial cells, and this is what starts the formation of a clot. So tissue factor starts aggregating platelets. So platelets start coming together, and then there is something called the clotting cascade, which is a complicated series of steps that lead to the formation of a fibrin clot. So fibrin is then the major clot former. Fibrin forms these strands that then aggregate more platelets and red blood cells, and you form this giant clot that then can either stay in the location or it can actually dislodge and travel to the brain and form strokes, to the heart for heart attacks, and to the lungs for pulmonary embolisms. So there are a number of medications and things that people can do to break the cycle at different points. So for example, for platelets, aspirin is something that is used to help make platelets less sticky. So aspirin can come in here and make platelets less sticky and inhibit the formation of clots. Certain substances like nattokinase, which is a natural substance that can break apart fibrin clots, can be used. There are a number of medications that work on the clotting cascade itself, like warfarin, for example, works on the clotting cascade to help block the formation of these clots and then prevent some of the more downstream manifestations. Specifically for the SARS-CoV-2 virus, there are some things we can do in this area here to help prevent the release of tissue factor and then the whole clotting cascade. Hydroxychloroquine can do it. Hydroxychloroquine can come in here and block NADPH. So hydroxychloroquine is going to come in here, block NADPH, and there's going to be a downstream blocking of the whole clotting cascade with the virus. Something that can also do it is spirulina. Spirulina has something called phyllocyanabins, which are one of the proteins inside spirulina that can block NADPH. Typical dosage around that is 15 grams per day to get an effective dose, which is not that much to get a really good effective dose. Something that can also do it is glutathione. Glutathione can come in here and inhibit NADPH. So anything that's going to increase glutathione will help. So NAC is going to increase glutathione, lipoic acid, and ferulic acid can increase glutathione and block this step here of NADPH release. So there are some other things as well, but these are kind of the major ones that have been studied and looked at. I hope that was helpful, and you enjoyed that video.